Hello everyone. So this is just a quick video describing how I collected the data for the moment of inertia part of the lab, where we're trying to find the moment of inertia of this aluminum stick, both about the end point, so about the hole that's at the end, and then later about this point right here, so this more central hole. So first of all, let me give a couple of definitions. So a simple pendulum, and we've talked about simple pendulums in the first semester of this course. Remember, simple pendulum is a mass that's focused at the end with a lightweight string or rod. So basically, I have this washer that's tied, there's a string that's tied to the washer. I'm going to use that as my simple pendulum. And if I wrap this around, so something like this, remember, if I displace it by a small angular displacement, maybe 10, 20 degrees at most, and I release it, the time it takes to undergo one oscillation, so to start from here, to come back from here, is the period, right, of that simple pendulum. Then I also have this aluminum rod, right, this aluminum stick here, which is what we call a rigid body, meaning each part of this aluminum rod stays a fixed distance from other parts. So it's like a solid body, right? It doesn't move. It's not, you can't compress it. It's very solid. If I hang this aluminum stick from the end here, displace it by a little bit, and then release it, and it oscillates back and forth, then this is now acting as what we call a physical pendulum. So a physical pendulum can be anything. Anything that you pivot from some point, hang it, and let it oscillate back and forth. Okay, in this case, this aluminum stick is a physical pendulum. Now, the other definition that we need is something called an equivalent simple pendulum. And what that means is I take the simple pendulum and I adjust its length. So I'm going to adjust its length here such that the period of the simple pendulum and the period of the physical pendulum are exactly the same. So if I pull them back by a certain amount, so a small angular displacement, and release them, they oscillate together, right? So they both have the same period. Whereas if I use some other location, let's say I made it shorter, let's say right here, if I try doing it here, you'll see that these periods are not the same. See, it's becoming off very quickly. But if I do it right at this location, then the periods are the same. So this is called an equivalent simple pendulum that has that particular length. So basically what I did was I measured that length for you in centimeters. So from the pivot point down to the center of that washer. And that's going to be the length of the equivalent simple pendulum. And we will use that to compute the moment of inertia of this aluminum stick about its endpoint. Okay, and I describe all that in the handout and in the video. And then the only other thing we do is later, instead of oscillating about the end, we have it oscillate about this more central hole here. And what you're going to notice is that if we leave the simple pendulum to be the same length as before, so the same length that we found originally, so it was somewhere right around here, and then we displace them and let them oscillate, you're going to notice that again they have the same period. So what that says is that the period of this aluminum stick, when it oscillating about the end, is the same as the period of the aluminum stick when it oscillates about this more central hole. So what's special about this central hole, right, because it leads to the same period, this is called the center of oscillation. Okay? It's a point on the object that gives you exactly the same period as the previous point, which was at the end of the object. So this is called the center of oscillation of this particular aluminum stick. Okay? It's a very important point. It also has another name. Let me put this back from the end here. So we won't talk about this much in this particular lab, but in another lab I do with the sports physics lab, we use a baseball bat, right? And a baseball bat can act as a physical pendulum. So the baseball bat is oscillating about its end. And it turns out this location on the baseball bat is called the center of percussion. And it's the point at which if you strike a ball at that location, the center of percussion, there's no forces at the end where your hand is. So people will say, there's no sting in their hand. Or some people will call that location like a sweet spot, right? Because it doesn't lead to a painful hit. That your hands don't feel that sting because there's no forces there. So this location is very special. Today's lab, we're going to consider it just to be the center of oscillation. It leads to the same period. In other labs, it's also called the center of percussion, okay, where there's no forces at the end here. All right, so hopefully that will give you enough detail to complete this part of the lab with the moment of inertia. Thanks.